Okay, we're going to begin constructing some points of concurrency with constructing the centroid. The centroid is one of the centers of a triangle. So let's begin by just drawing some triangle. We're choosing to not necessarily make it equilateral. We don't want it to be too special. So we have a triangle, and the centroid comes from three medians. So the question is, how do we construct a median? Well, a median goes from a vertex to a point on the opposite side that is the midpoint. So we need to find the midpoint of this side. The construction skill we'll use, using our compass, is to construct a perpendicular bisector, which will not only give us the bisector, but a side benefit of a perpendicular line. We're not going to use the perpendicular line here, but we'll go more than halfway, copy that same distance from the other vertex, and it constructs a little football. If we now take our straight edge and connect those 2 points of our football to find the point in between, this point right here is the midpoint of the line. Another way to express it would be to demonstrate using hash marks that in fact it is bisected. Now I can connect that midpoint to the opposing vertex, and I've constructed a median. That's the median of the triangle. Now I'm going to do the same thing from other sides over here. Still go more than halfway. And connect those 2 points to find the midpoint of this side. Which suggests that this side has been evenly bisected. And if I connect that median, midpoint to vertex, I have now 2 points that intersect, which isn't surprising. Any 2 lines with different slopes will intersect. But now when I do it from the third side, more than halfway, construct my third midpoint, demonstrating that it bisects this side as well. And when I connect it to the opposite side over here, if I've done it carefully, it should meet in exactly 1 point. Now in this case I kind of missed. I think it was over here. I slipped a little bit and it should have been farther over. So my midpoints on each side, when connected to the opposing vertices, will construct 3 medians. Those 3 medians should meet in what's called a point of concurrency. In other words, they all meet in a single point. And specifically, when I'm dealing with 3 medians, that point is called the centroid. Its significance is center of gravity. In other words, this is the balance point. If you were to cut this triangle out of paper and try to balance it on your finger, that would be the point where you'd want to stick it on top so that it balances. And that concludes construction of the centroid.